Hello and welcome everybody. My name is Kevin and we are the Fantastic Five. On October 6th, we were deemed best overall at the GenQ Quantum Computing Hackathon, and we'd like to share with you our presentation because we think that this could be a tremendous benefit to the city. Let's begin with a story. Imagine John.
Quantum superposition between two states.
All right. Imagine John. He's had a long, hard day, and all he wants. Oh no, there's been a huge dump of snow. That means slow traffic with lots of accidents, made 75% worse by delayed plows. But that's not the worst of it. There's no way he's going to be on time to pick up his child from the daycare. This makes John so angry. So what can he do? Well, do you want to be the one to take his call? Do you? Do you? Me not. But real people that we interviewed during the hackathon are in the same boat. Alice here has given up calling 311. And Tom, who's a doctor, has been locked in so many times he's always worried that he's not going to be able to get to the hospital. And Emma, knows that there is a road clearing update map, but it's not really good for driving with. And they're not the only ones. According to the latest citizen satisfaction survey, 98% of Calgarians say that road clearing is a priority, is very important, but only 70% think that the city's doing a good job of it. Only one other service ranks worse in those two categories, and that's affordable housing. What's more, in 2022, additional $10 million was added to the snow clearing budget. Hasn't improved it. This is a red flag. When the GenQ Quantum Computing Challenge came up, I saw this as an opportunity to help my fellow citizens tangibly. I've gotten stuck in the snow too. This was personal. Japnit, is our team up to the challenge?
Yeah, we are. But the challenge is not as simple as it seems. There are other factors in it, including road width. Not all Calgary roads are the same width, as well as real-time traffic conditions, or the fact that it's harder for snowplows to take U-turns. There are other things like some roads are priority, and there needs to be certain priority zones, as well as some roads have construction going on. So we had to account for all these different variables, which made the problem very complicated. But don't worry, because this is exactly what we wanted to do at the GenQ-Hackathon, and our team was up for the challenge. We had 2 software engineers in the team, we had a few quantum people, as well as a business thinker who could make sure that we come up with a viable product instead of getting stuck in the theoretical quantum stuff. And after juggling work meetings, 2 sleepless nights for Jamal, and I think we're in like quantum superposition again.
Let's use the computer.
Yeah, let's use the computer.
Superposition is everywhere, right?
So after 2 sleepless nights for Jamal, juggling work meetings, submitting the solution after literally 500 tries, singing on the rooftop, and making 50+ Canva slides for our 3-minute presentation, it was all worth it because we ended up winning. And not only did we win the sub-challenge, which was the snow plowing sub-challenge, but also the entire hackathon. Sorry guys, something is up.
Yeah. It's not you. Like, this is we just moved in last week.
Okay.
Our internet is hanging on by a
Okay. So this is the solution we came up with in just 48 hours. Our vision was to disrupt the current road planning mechanism used by the city. This would help not only the city, but the citizen as well as the snowplow provider, because we would be able to optimize the routes in a way that we clear the routes faster while saving CO2 emissions and saving fuel. So this is our solution, Street Guardian. It's a hybrid solution which transforms the Calgary road conditions map into a powerful quantum-powered Google Maps type application. And yes, we made like a small beta during the 48 hours that we had. So let's go through a demo. Imagine you're the car driver. You want to get to your work safely. Now you can see which roads have been cleared in real time, as well as be able to report certain lanes which haven't been cleared, which might be a shortcut to your work route. And all of this dynamically feeds into a central database which would optimize the route then to able to change the routes for the snowplower to make sure all streets of Calgary are cleaned. This is what it would look like on the City of Calgary side of things, the planning dashboard, where you can account for construction, you can account for any road congestions, be able to track each snowplow, see how much they have done, be able to contact them to reroute them, as well as take into account priority zones. Certain zones need to get cleared first, and as well as more information like the updating traffic conditions, or let's say an emergency vehicle is stuck in snow and you want to reroute the snowplow for that. Or citizens are reporting certain lanes, as well as the updated weather conditions. So this problem is very hard and complicated. Jamal, how do you think we can solve it?
Yeah, I think we have to do some magics, but there's a fine line between quantum and magic. Trust me, whenever I talk about superposition and entanglement right now, as you can see, my friends think that I'm a magician, but I'm no magician. I'm a quantum physicist, and I'm going to walk through you to the quantum principles here. So in classical situation, we have bits, which is 0 or 1. But in the quantum situation, which is a qubit, we have 0 and 1 at the same time. And let's do the thought experiment here. Let's see, we have a cat, and we are going to put that cat in a box with a poison. And if we don't look in the box, we could say cat at the same time is dead and alive. What does that mean is this is the superposition between 0 and 1. That means 0 dead or 1 alive. Exactly. So we are on the both slides at the same time, and that has a probability. And that probability distribution is over all of the presentation, as you can see. And we don't know when does that happen. So that's the entanglement, right? That means two qubits are interconnected to each other, and they are making one object, and that makes 4 possibility outcomes out of it. So that makes it super powerful. Let's think of the entanglement as 2 qubits that are playing seesaw. That means affecting one of them affects the other one. And that is the entanglement. And as I mentioned, these two are making the super powerful quantum computer. And what does that mean is when we are considering like classical situation, we have to like try each of those roads one by one. But in the quantum solution, we have the superposition and entanglement. That means we are trying all of the possible situation at once, and we are finding the solution much faster than the classical counterpart. And that's the power of superposition and entanglement. Let's go to the mathematics here. In a real situation, we have this quantum path that tries the minimum, global minimum much faster because of the quantum tunneling. But in a classical situation, that red ball should go all over the place and find the global minimum one by one. That's heuristic, and that takes time. But in a quantum situation, that takes much faster because of the quantum tunneling. So how we are gonna use these powers of the quantum approach, because quantum is not enough. We have to use the classical computer at the same time, because it turns out hybrid solution is the best solution. Think of quantum processing unit as a GPU. It has to be CPU somewhere, and classical computer is CPU for quantum processing unit, because we are using that for optimization of the parameters, and the hard part could be delegated to a quantum computer or quantum processing unit. During the hackathon, we tried different optimizers in IBM hardware and different ansatz, and it turns out the best solution is Kobila for the runtime. And the reason why we did that is because we have a realistic configuration. We have to come up with the best option so we can tackle this problem efficiently. It turns out, based on our simulations, if we can simulate 12 nodes with the quantum computer, we can outperform the classical counterpart. And if we look into the history of quantum hardwares, we are seeing that there are a lot of new players coming to the game, like Rigetti, Google, IBM, and D-Wave was there for a long time, 2007. And D-Wave is showing some outperformance and real applications of quantum, as we are going to see. So this field is growing, but how we are going to use this power of quantum and use it right now? It turns out if you use D-Wave and NVIDIA at the same time, we could use GPU, CPU from hyper-performance computers that NVIDIA provides, and GPU from D-Wave, and put them together to give us a real benefit. And it turns out, based on NVIDIA's characteristics of the communication back and forth between GPU and hyper-performance computers, less than 10 seconds it takes that you communicate with the GPU and get the result out of it. So if you want to make a real application that is realistic in real time. So for going forward, this is the D-Wave's computer. In a recent research, it shows that in the vehicle optimization road problem, they tried different CPU for like normal computer approach of solving it, or QPU from D-Wave and hybrid approach. It turns out for the small size of the problem and the medium size of the problem, like hybrid approach is outperforming or having the same result comparable to the classical scenario. And that's not only it. This is from the previous D-Wave's hardware. This is the newest topology from D-Wave that has much more entanglement between qubits, and based on topology is much better than the previous topologies. What does that mean is, if we see these results from the previous research, we are seeing that always the hybrid approach is much better than the classical approach or comparable. Let's imagine what would happen next. This is gonna come like in 1 or 2 years, because D-Wave showed this topology in 2021. So it's gonna be released soon. And that's why we can do quantum right now, because we can do fast optimization in less time and less fuel consumption, which is aligned with the city goals. So classical computers brought us here so far, and we are so grateful, but that's not enough, because classical computers based on Moore's law are seeing a Plato, sorry, not philosopher, the other one. But the quantum computer can outperform these classical counterparts. And today is the opportunity to invest in quantum and see the benefits for the future.
Okay, that was a lot of quantum stuff and graphs, and I'm a software engineer. It went all over my head, kind of. I hope you guys are still awake and with me. So like Jamal said, the classical computers have done whatever they can, and now the transistors are so small that we are entering the quantum realm, so it's time to start thinking quantum now, because in the next few years we will be ready. And then now, let's slice the elephant, because I want to show you how we can solve this problem today. And don't worry, no animals were harmed in the making of this presentation. I know we used a cat and an elephant, but everybody is safe. And the way we want to solve the snow plowing problem now is by subsectioning the city. We can use a divide and conquer approach. That means that we don't need to solve for the entire city right now. If we can solve for certain subsections, we can stitch together the map to get here in the next 3 to 5 years. Quantum will be powerful to solve the entire city in one go. But right now, what we're suggesting is a hybrid approach which uses classical and quantum computing. Let's see how we can get there with a realistic roadmap. So we had this amazing hackathon, and in 48 hours, we built a very great solution. So what's next? If we start doing research now and collaborate with the key stakeholders of the city, we can have the first prototype complete in the next 3 months. This means we'll have a quantum model which is ready to solve smaller problems with the current DWare hardware that is available right now, as well as work on the application side of things to get the snowplow operator app ready, as well as the planning dashboard. Perfect. So, and this, with starting research now, we'll be ready to pilot something in the winter of 2025, maybe not for the whole city of Calgary, but at least downtown Calgary, so that we can optimize the routes for the snowplowers daily, as well as enable real-time tracking of the road conditions, as well as the snowplow locations. And while doing this pilot test, we'll be able to gather critical feedback from the users, as well as the city, to improve it in our next phase, where we'll integrate the feedback and optimize it. And the best part is that this snowplowing solution not only applies for snowplowers in winters, it can also apply for Calgary street sweeping, which happens in the summer. And this application can be applied to different industries as well, like garbage, delivery, agriculture. All of these use vehicle route optimization. So once we solve this problem for one problem, where we can actually expand it and solve it for the entire industry. So for the past 20 minutes, we've been trying to convince you guys that quantum is amazing, but maybe hearing it in the words of someone who's your own will help you. And David says that our world is a big quantum machine, and what will we uncover if we actually rebuild it using the quantum laws and the power of quantum? I would like to thank the City of Calgary and QAI Ventures to host this amazing hackathon that gave us this real-world scenario to work on, as well as having the city improve our product within 48 hours, and this opportunity to share our solutions with all of you. And I just want you guys to imagine, we met on the day of the hackathon, 5 people, 2 of us are in different countries right now, 3 of us are here, and we met on the day of the hackathon. Within 48 hours, this is all that we came up with. Imagine with the real resources, like enough resources and time, what we can achieve. Because quantum future is not that far. That's why City of Calgary, let us start your quantum journey. Thank you so much.
Okay, so I do want to open up for questions, but so what's next? What's next for you?
I mean, you can see the roadmap, right? We can start right now and do the R&D and keep things going, because right now D-Wave has a lot of open source documents that people have worked with these type of algorithms and came up with real solutions. So we could bring all of them together and customize for this problem.
Okay, but the UFC is big for spin-offs, right? Like they help spin up startups. Some of you are UFC involved. How did you guys get involved in the Quantum City then?
So I was working as an intern in QTI Quantized Technology Incorporation in Quantum City. And after this, like in a month, after I'm graduating from University of Victoria, I'm going back there as a full-time employer. But other people...
So I don't know that much about quantum. The hackathon was my first introduction to quantum. I know I'm a machine learning engineer and a software engineer. I'm currently building another startup in Canada. I just graduated like a few months ago.
I have a bachelor's degree in computing science and 3 years of software development experience. I have been exposed to quantum computing concepts before, but this quantum computing hackathon was my first hands-on exposure, and I was actually quite interested in it.
So will you be taking this, is this a startup idea that you're going to take to platform, or what's next?
I think that's what we're here for as well, to see if David would be interested in us.
Yep.
Let's ask the audience, who here thinks that this would be something worth pursuing?
Woo!
I call that a resounding yes.
Good stuff. Okay, I did have one more technical question, though. Okay, so when you were running your tests, where did you get the compute power to do that? Like, you weren't using computers, right? Were you using cloud, and how did you get the compute power to run your tests?
So for those IBM tests that we have done, those were provided by Sandbox, like the company in, is it in Mexico? Yeah, QCentroid. Yeah, Spain.
Okay.
Those are these
Yeah.
that are from like using cloud. And for DVA ones, those are just papers that showed these results. And
Right.
for DVA, yes, there are some cloud access, like open source access to the cloud of DVAV that you have to purchase, but I had like 1 minute free access, so I played with it. So 1 minute is a lot, trust me. Like I used like 3% of 1 minute. And if you want to like do something like this, you can do it in
Wow.
1 minute.
Okay, we need to play with this. And Dave, you know, one of the things that we've done here is, you know, we have standard IT equipment and standard software, and one of the things that Dave, you really championed is having our own network, but then having access to a local cloud company, even just to do our own AI, right? So we're using Denver data.
Works for AI.
Yeah.
But if these cloud compute for quantum is available, we can connect there as well.
Great.
So.
Any questions from the audience? Okay. Thank you all very much, and hope you can hang around for a bit, and we'll give you a bit of a tour. That was amazing.